All right, we are moving into section 5.2, and you're going to find that 5.2 is very descriptive in nature, again, just like 5.1. We're going to do a little bit more to connect the visual, the graph, to some of the factoring and some of the solving that we've done in last chapter. So 5.2 is called Polynomials, Linear Factors, and Zeros. And I'm starting with this first question of what is the same and different about calling something a zero, a root, an x-intercept, or a linear factor of a function. So when we think about, I'm going to actually start with the factor part. When we think about something being a factor, you're going to have it written in parentheses. So something like x plus 2 is a factor. I can list a bunch of factors. I can do like x minus 3. I can do x plus 5. Those are all called factors. As soon as I set those factors equal to 0, now I create a situation where I'm going to ask you to solve. So when you solve, you find things that we call zeros, we call them roots. They both mean the same thing. And it's where each of those factors equals 0. So for example, the first factor equals 0 at -2, the second one at 3, the third one at -5. These are called your solutions, they're called your zeros of a function, and they're also called roots. All of those words are synonyms. When we talk visually about what that means, these all represent places where it crosses the x-axis. So they are also x-intercepts. So if I go over to -5, I can put an x-intercept there. So I can put a little dot, -5, there's an x-intercept. I can also put an x-intercept at -2. I can also put an x-intercept at +3. So the intercept is the visual part on the graph. The factors are the pieces that are written individually in parentheses, and the solutions, the roots or the zeros, are the list of x values that make that equal to 0. So we're going to quickly recap what does it mean to have factored form versus like a standard form. So if you look at these are in more of a standard form. Factored form means you go through that checklist of factoring that we did last chapter. So you want to see, can I take anything out? So for this first one, I can take out an x, which leaves me with x squared minus 2x minus 15. And then I can actually go further because this factors as a basic FOIL factor. I need numbers that multiply to get -15 and add to get 3, or excuse me, add to get -2. So that would be x minus 5 and x plus 3. So that is called factored form of my polynomial. Same thing for the next one. The next one has a GCF of 2x, which leaves me with 4x squared minus 25. We can go further with this one as well. 4x squared minus 25 is a difference of squares, so we can break that down into 2x plus 5 or 2x minus 5. And again, every time I factor, every factor of x is creating another solution or 0. It's also creating another x-intercept on the graph. So if you're given something like this that is already in factored form, you can very quickly find the zeros by taking each factor and setting it equal to 0. So my first factor, x plus 2, would equal 0 at -2. So we would say that's one of our zeros or roots. The second one is at 1. The third one is at 3. So on my graph, what I can do is I can go to -2, put a point, +1, put a point, and +3, put a point. And I know for sure that those are 3 places where it crosses or touches the x-axis. To finish it, I can use a calculator to go through and graph. So I'm going to go to y equals, and I'm going to type in the entire equation, and you can keep it in factored form. You do not have to distribute it and FOIL it to get it back to standard form. Calculator doesn't care what form you enter it in. So I'm going to use parentheses a lot, and I'm going to type in each factor in its own parentheses, and then I'm going to hit graph. And you'll see as the graph is formed that it goes through those 3 x-intercepts that we expected, -2, +1, and -3, or +3. And then we can connect the dots by going here and saying, well, I know it goes up through here, I know it goes down through here, and I know it goes up through here. And I'm not getting too picky as far as how far up I go and how far down I go, as long as I have that general shape of the graph. Same thing with this next one. I have 3 factors of x, which means I'm going to have 3 zeros or 3 roots. 0 makes the first factor equal to 0. 3 makes the second one equal to 0, and -5. So on my graph, I'm going to go 0, so it's right at the origin, 3, -5. And then to fill it in, I can go to my calculator, and I can type in this entire equation. So x minus 3, x plus 5, hit graph. See, a lot of it's off the screen. It's very high. So it starts downwards. It goes up through -5 and then down through the origin and then back up through 3. So when I draw it, I'm just going to kind of draw it real quick here. Got my thick highlighter going there. The other thing I might notice is when I multiply this all together, if I would end up with an x to the third power because I have an x, an x, and an x all being multiplied. And what I learned in the previous lesson about end behavior is an odd function, x to the third is an odd function, will have opposite end behavior, meaning if one side goes up, the other side goes down. And you can see that on this one. This left side is going down and the right side is going up. So here's what you're going to have to do on Delta Math. So on Delta Math, you're going to be given something like this, where it's going to say, what are the real solutions of a function f of x equals 0? So I'm going to show you this one that's already done for you so you can get an idea of what's being asked. So you're going to be given a graph, and the little yellow dots were added with the solution. They are asking all of the places where the function equals 0. So they're asking you to list the solutions or list the roots. All you are doing is typing them in one at a time into your solution box. So there are 4 places that this graph touches or crosses the x-axis. It happens at -5, at -6, at -4, and -8. Notice they didn't even put them in numerical order. As long as you have the 4 times, you're good, you're correct. So let me show you one that's not done. So this one is asking the same question. What are the following are the solutions for f of x equals 0? So I am looking to see when does it cross or when does it touch the x-axis, and then I'm going to list them. So from my picture, I can see -8 ends up being a solution, -1, and +4. So when you type them into your screen, you're going to type in -8. You can hit the little plus sign to give you another one, or you can hit a comma to give you another spot, and then you're going to type in -1, and then you have another answer. Your third answer is +4, and you're going to submit that. So that's what this section is asking you to do. It's going to give you a picture. It could be a very complicated graph. It could be a very simple parabola, and it's asking you to find all of the real solutions, which again are all of the places where the function equals 0, and you can see them visually by where it crosses or touches the x-axis. So that's the first part of 5.2.